Okay, now it's really a little big lab. However, this lab very close to the lab we already done, lab 11. Okay, I just quickly go through that, through the schematic. And you understand at this time, I already given to you the sample program. And I will be talking about that sample program. That means you don't have to edit too many things, just a very little to get your software done. The thing is your job, not try to writing any software. But in the training here, we cannot avoid it. So that's why. At this time, we given you a very little, not much in the software. Your job will be when you build the circuitry, you run your test program. If they fail, then you have to know how to fix it. That is your job. That is learn how to troubleshoot it. So the first thing you can see on this one, you already know U1, 164, serial to parallel. Okay, like you said, you send 5.5, you can get 5.5 here in parallel. And this parallel will be input to U3. That's just a buffer. They will be go into the output, if pin 1 and 19, 0. And in order for pin 1 and 19, 0, they're coming out from U8. Pin number 4 must be 0. Depend on input AB here, 0, 0. Pin 4 will be 0. So they're going out here, they're going down, and they wrap it into U2 and to reading port C. Okay, so that will be 2 tests for testing U1, U2, U3, and part of U8. If you get any question, just let me know. Okay, this already happened in lab number 11. And the next one, they want to test U6 here and U5. So first thing we see what U6. U6 374 F trigger D flip-flop. Okay. That means you can send data to U1, go to U3, and they will be ready right here. Input D, U6. If you want they go to the output, you need to apply positive clock, pin 11, from U9, pin number 4. Okay. You can see U9 here, pin number 4 here. Basically, that also coming out from U8B. Okay, so if you get the clock at pin 11. So the input here will be go inside U6, not outside yet, until pin number 1 output control have to be 0. Then output now ready here. Okay? And the output already here. And you can see they can go into input U5. Okay? So there you go, input U5. U5 is 541 buffer. In order for the input here go to the output U5, you need pin 1 and 19 of U5 must be low. So the data will be coming here. Okay, you read port C again. Verify data 55. Now, if something wrong on this test number 3, so you don't care about U1, U3, and U2. We already tested. Okay? So this test fail, they can be U5. They can be U6. And they can be U8. Okay? And U9. That is, will be helping you to troubleshoot it. And then they can get the next test will be the same thing. However, the difference will be in data AA. We already telling you all the time. Any input, output of the binary, you have to test with two different type data, 0, 1, 0, 1, 1, 0, 1, 0. Okay? So if the test number 4 it failed, that means either U5 or U6, not U8, not U9. The thing is to get it wrong with U8 or U9, they must be failed test number 3, not test number 4. Only thing is the student can do the good job, that means after you build, you run the test. If it failed, then you're able to figure out where it's wrong, what's wrong. Okay? Then the next test will be testing for memory.
Mr. Frank, could you take a question?
Yeah.
You said, okay, it went through the first 3 tests, correct?
Right.
And then you said it failed on test number 4?
Number 4, it failed. That means either U5 or U6.
Yeah, one of those 2 are bad.
Yeah, either one, I don't know.
Right. I understand that. I just want to make sure I heard you say what you said.
Yeah, but it's not U8.
Correct.
Not U9.
Correct.
Something wrong with U8 or U9, they must fail test number 3.
Right. So if test number 4 fails, it could only be 5 or 6.
Exactly. The thing I already telling you, you done the board and you test, now it failed. You want to solve the problem, okay, and you don't know how to do what to do, then just online with me. Then I will be help you to solve the problem quickly, telling you how to do what to do. Don't do anything if you don't know what to do. When I'm saying electronic, it's not lucky. Okay? So, next test will be testing for memory here. Memory is very simple. You want to test, you write data to location inside the memory. Then later you read them out. Make sure what you wrote in, they will be the same as you reading out. Now, in order to test U7, first thing you need to apply a thread to the memory. Okay? If you want to apply a thread AA, then you can send through U1 AA. So AA here, enable this guy, AA will be here. Now, what we need to make sure AA will be go here. In order to do it, you say 74,373 D large. If you get the AA input here, in order to get inside U4, you need to set U4 11 to logic 1. That coming out from U9 pin 2. So when LE pin 11 at logic 1, then also output enable pin 1 already run. They will be coming out here. Okay? That is how they work it. If you send the data AA, come here AA, but not AA here, something wrong with U4. Okay? That's only wrong. And also make sure pin 11, they must be 1. Okay? That apply a thread. Now, after you apply a thread, you need to apply data here. Now, that data here, they go into right here. U7 pin 9, okay? They go in here, they can go back to the system through U5, or they can come in to U6, okay? So you want to write data, 55, for example. So you get a 55 here, enable U3, 55 will be here, and going down here, you need to apply the clock, and the output control will be 0, so 55 will be here. So now you already get 55 here, and the thread will be AA here. Only thing what you need will be apply. Write have to be 0, PD pin 4 to write. PD pin 5 output enable have to be 1. The thing is you write data in, not out. Enable here will be going 0, 1 to 0, then 1. So the data here will be go to the address here inside. That's how to write a data to the memory. And if you want to read data from the memory, so the first thing you have to tell what location, what address you want to read. Then you have to apply address. Okay? And after you apply address, then you have to apply pin 21 right to be a 1. Pin 20 output control to be 0. Pin 19 enable will be 0. So depend on what location address here, data will be coming out. Data coming out now, they go this way. They go here and they go to U5, then you can verify to U2. So you can see almost like the lab 11.
Mr. Pham, I think that was just a little minor error. You meant pin 18 because 19 is ground on U7.
U7, what pin?
Pin 8, you said 19. I think you meant 18.
That will be 18, right?
Yeah.
18 will be 0 for
Yeah.
reading.
So reading 21 is logic 1, 20 is logic 0, and 18 is logic 0.
Exactly.
Thank you.
Okay, now you can see in here, output of the memory, also they go to U10. U10 will be 373, the large. That means when you get the output of the memory, they already here. You want to get to the output here, you have to get U10 11 to be logic 1. Then whatever input here will be go to the output here. And that output will be go to DA converter. Now, this is DA converter. This circuitry we already get through it. That coming out from U10. If you apply on 1, that means the full scale output of I out pin number 4 U11, they will get very close to 2 milliamp. Go to the circuitry, this is current to voltage converter. They will be converting to the voltage here, and you can get around 9.96 volt analog voltage. Okay, and that analog voltage go to R4. Okay, right here, 9.96, almost 10 volt. Now, what happened here? LE15, that ADCOA. So this IC will be converting analog voltage to the binary voltage. That's only thing. However, this IC only handle maximum at pin number 6 is 5 volt, cannot be higher. So that's why when you get the output from DA converter, almost 10 volt. So you can see in here, they get a 10K, 10K, that means they divide by 2. So if you get 10 volt at this point, in here will be 5 volt. Okay, now I try to explain to you again. The reason we have divide by 2, but the thing that did I see in 15 cannot handle any voltage higher than 5. Okay? And also you see you get the capacitor here. You know what that name for this part here? Why we needed capacitor here? This capacitor that for they call sample and hold. Let's see, I can type in here or not. Oh, cannot type in it. I don't know. That's what they call a sample and hold. The purpose for the capacitor here, when you get a 5 volt capacitor charge to 5 volt, to make sure very stable at this point. Then you go into that circuitry. What's the name? Okay, telling me the name of that circuitry U14.
Unity gain.
What's the name? Say again.
Follower.
Unity gain.
Follower.
Follower.
Yeah.
Follower. Follower means input at 3, output 6, identically the same. If you get 5 volt here, then you get a 5 volt here. Okay? Then you can see anything here, you don't have to do anything. Whatever they do, okay, they already make a connection here. You follow the connection. And only thing you need to apply up pin number 3, PD pin 3. Okay. High, low, high. Then they will be take 5 volt here, converting to the binary. Okay. And when they converting to binary, to output of U16, they go to U2. That means they will be go into here. Okay. U2. Then the computer can read port C. And after they read it, and they have to do in calculation, convert it binary back into the voltage. Okay. And telling you right or wrong. So this is automatically testing. We don't have to using the meter connect here. Okay. They will be telling you output right or wrong. That is the circuitry 1 for D to A. Okay, binary converting into the analog voltage. Then they go into A to D. They converting back analog to binary. Okay. And after they reading our binary here, they do the calculation. We'll be telling you pass or fail. That's the whole circuitry for the lab 12 or 30.
Just quick question, Mr. Pham.
Yeah, any question?
Yeah, is there typically a problem with U15 pin 4 and 19, and then also the 8 bits of binary data that comes out of the pins 11 through 18?
Right here, right?
Right. So the data that comes out of 15 going into, where you're at right now, is there typically a problem we need to look for there?
Now the thing is, this coming out, you cannot measure output to be C high or low. You understand it? If you get a 5 volt here, output supposed to be on 1, right?
Okay.
However, that converting analog into the binary, they cannot be exactly. Okay?
Mhm.
You have to know which input will be given to you, any voltage from 9 to 11. Okay? So that's why you cannot.
So you could have mostly ones, but maybe one or two of them will be a 0.
Exactly.
Okay. And then the other question is on pin 4 and pin 19, where R6 is at. One of them's frequency and one of them should be like 2 point something volts or whatever.
Right. If you know when you build it, you can say pin 4, that will be the clock in. So measure in right here, you can see the frequency at pin 4.
Yeah, you'll get a frequency. And then pin 19, you'll get a small voltage.
Exactly.
Okay.
Okay, any question on that one? Now, before we go into that thing, okay, I want to show you the sample file I already upload to you before I can go in a little more detail. How come that one not show me? Oh, okay, I get the wrong one. This is the one. Okay, this is the one sample. Before you want to do it, you create your new project, everything. Then you control A. That means you copy everything here, paste into your program. Okay? The thing I already given to you, everything. That means on of the function decoration, I already given to you here. Only try to understand. Okay? Also, everything here, you don't have to do it. Now, On the test number 1, I given you everything. You don't have to do anything on test number 1. Test number title, expect data, math, pick up, and first thing you need to send the serial file. Then you enable U3. Then you reading proceed. Test evaluation telling you pass or fail. That is the first test. Any question on the first test? I make for you very easy way to working on your software. Anything? No? Now, okay, let's see. Just wait for me. I go to the web. Download. Okay, let's see. Here, CPP. Okay, that's what you will get it. Okay, that's number 1. Okay, you have to send serial function file. And in here I say enable U3. So what you need to do is call the function enable. That means you have to type in enable U3. Then here you don't have to do. Read verify. That's number 2. Now, I have to telling you, send serial AA. Then you have to call that function to do it. Enable U3. You have to add in function. Enable U3. Then you can do it. Okay? That's number 3. I'm not doing for you, but I'm telling you what to do. First thing you need to send serial file. You have to enable U3. You need to apply the clock to U6. You have to enable U5. So that will be done. And the next, test 4. Okay, this is what you need to do. Same thing. Test number 5. Test memory. You have to call the function write to memory address, write to memory data. Then you call write to memory. That's the first. Next one, write to memory address file. Write to memory data AA. Write to memory. And now you're reading. You're reading. You need to write to memory address what location you want to read. Then you go read memory. Okay? That number 6 will be the same thing. And the rest of the test will be, you don't have to do anything. I already did everything for you. Okay? Only thing we have to do right here, void enable U3. I asking you to adding your code there. What you think you can write in there?
Write to port B.
Okay, now see in here. Let's see. Here, that's what you need to do. Okay, enable U3. You need to write to port B. For example,
0x00.
exactly, 0x00. If it passed, you okay. So that means in here, okay, you have to say write to port B, right?
0x00.
Write to port B 0x00. Another one, enable U5. Okay, they can set edit here. So now, if you go enable U5, what you will be writing here? I don't know. For example, you say 0x
22.
1 or 2, whatever. No,
0x22.
0x02.
let's see. Okay. That means now you can go into here. You can add it right to port B 0x02. And then you can keep doing enable U16. Okay. Whatever I want you to add it, that means you have to add it here. Okay. And U for last, add it here. Everything coming from here. Okay. Enable U16, U for last, U6 clock, U10 last. Write to memory. Okay. Write to memory address. Then basically you can get this thing. You don't have to fill in anything. Okay. Make sure you copy that into your. That is what you need to do. If they pass everything, then you can go to edit your program here. Okay. Edit here, edit here, edit here. For you for that. And after you're done, make your compile without any error. That means your program ready. Okay. You see that on the main program. You can get that more memory ADC data. Okay. Or you can see in here. Let's see. Then you can test ADC. Okay. And you can test complete memory test. So let's see. We're looking on test memory ADC data. Test memory ADC data. See right here. I already did everything for you. You don't have to do anything. Okay. That is a function. And if you want that ADC, and this is a function definition, that ADC. And everything here I already did for you. Okay. After we're done, next time I will be going into the detail for each function definition here and try to explain to you how they working with the software here. But in order for your job to be done, this only thing, we already make everything for you, okay? That go to the end of that ADC. That means this software here, you cannot change anything. We already did it. And will be explained to you. Next meeting, in detail for what we're doing here, okay? What we're doing up here and what we try to do. Next one here. When you understand once, the rest will be deep, same thing. Okay, any question, anything? Try to get your software done first. You get any error, any problem, just let me know. I can help you quickly, okay? I want this lab to be done before June 30. That means the last day. Start the new date for the summer. So basically, you can get 1 to 3 weeks. You can get your software done first. And you're not done for testing your hardware. Then you'll still be okay to get the certificate report. But you try to get your hardware done. First week, second week of the summer. I hope at that time the certificate will be returned to me. Then you're ready, okay? And another thing, if you want to apply for a technician job and you don't know how to make the resume, then you just email to me. Maybe I can help you.
Thank you.
I need help with my resume, Mr. Pham.
Kumi and Viola will be done by Sunday night.
Yes, Smith.
Kumi will be done by Sunday night.
Yes, and I will be done Sunday morning.
Yeah,
See, working harder now.
Yes.
it's about time.
Too long in the program. You don't want it. I don't want either.
All right, Mr. Pham, thanks a lot.
Thank you.
Yeah, you are welcome. Okay.
All right.
So have a good holiday.
Okay.
Same to
Some
you.
people, some people already go.
Thank you. Good night.
All right.
Good
Yeah,
night.
thank you.
Bye.
Bye.